Scientists, and happy Tuesday. Today I think is our 14th day of our unit and like our 36th day of distance learning. So crazy. You guys are doing an awesome job so far, and I am so impressed and proud of you every single day. I know it cannot be easy doing distance learning from a student perspective, and believe it or not, it's not super easy doing it from a teacher perspective either, but it's your motivation and your awesome work that keeps me going. So I just want to say thank you. You are on step 1 for today, which is watching this video. I'm going to go over our work from yesterday, and I'm also going to introduce our assignment today. And then your assignment today is going to be to complete assignment 14, which is actually a game called Who Wants to Live a Million Years? But we'll get into that. So going over our work from yesterday, the first question said, what do you notice about these mice? So number 1, they're pretty adorable. I'm not a fan of mice. They kind of scare me, but they are pretty cute. What I noticed, and a lot of you noticed, is some are brown, some are tan, some are white and tan, some are bigger than others. Like this one looks pretty big, that one looks pretty small. So different sizes, very similar eyes. I would even say pretty similar ears, although I'm sure some of them have bigger ears than others. This one's ear looks kind of small. This one's ears looks kind of big. So those were just some mice noticings, is that they, like moths and like foxes, have variations. Now, these variations are caused just by sexual reproduction. 2 mice have babies, and all the babies look a little bit different. However, with the moths, that was not caused by sexual reproduction. That was rather caused by a random genetic mutation, which we've been talking about. So then I give you this data table on dark gray mice and tan mice. And the population of dark gray mice seemed to decrease over the past 4 years, whereas the population of tan mice seem to increase over the past 4 years. So tan mice are going up and dark gray mice are going down. So based on the data above, what can you conclude about the environment the mice might have been living in over the past 4 years? Well, I would think that because light mice are going up and dark mice are going down, that the environment probably favors those light mice. So maybe they're living in a desert area, maybe they're just living in an area with light colored environment. So I would assume they're living in some kind of a desert area, but as long as you said that it's an environment that favors those light mice, that would be good to me. I don't know exactly what eats mice. Snakes, maybe some kind of birds. So those light mice are probably doing a better job of blending in and getting food than the dark gray mice. This one, some key components of natural selection. I went over this in my last video. Time, many generations. It doesn't just happen in the blink of an eye. It takes a pretty long time. Variations are super important. If all the offspring looked identical, this couldn't happen. They would probably all die. You have to have some kinds of variations. You have to have a whole bunch of mice that all look a little bit different from each other, and some of them are going to be better at surviving than others. Asexual reproduction, that is not one, because asexual reproduction makes offspring that all look identical. Again, if they all look identical and something's killing them, they're all gonna die. So we don't want that. There has to be some kind of environmental pressures or some kind of changes, something forcing them to go one way or the other, something forcing them that tan mice are doing better than gray mice, or dark moths are doing better than light moths, or something with our foxes. Humans choosing which animal to breed and pass on traits. That's actually not natural selection. That is artificial selection. So artificial selection is when humans pick the foxes to breed together and pass on their friendliness gene, or they breed the puppies together to get the genes they want in the puppies. So humans choose which ones pass on their traits and survive and reproduce. Whereas in this, it's not that humans are picking, it's actually that nature is choosing who is going to survive and reproduce and pass on those genes. So, for example, with the moths, when they were in the dark colored trees, and it's not like the dark colored trees are choosing, but in this scenario, nature, the dark colored trees are kind of choosing who lives and who dies, because the dark moths are going to blend in with the trees and live, and the light moths are going to stand out and they're going to die. So humans aren't picking and choosing which ones live and die. And even the bird isn't really picking and choosing. It's just finding the ones that they can see best, which, depending on the environment, is one moth or the other, if that makes sense. Another important thing is competition or survival of the fittest. So organisms with traits that will help them survive will live, and organisms with traits that unfortunately don't help them survive will probably die or not have babies to pass on those traits. So why do you think this process is called natural selection? I kind of went over that. Natural selection, because the process happens naturally without human interference. In artificial selection, the foxes were chosen by humans to breed and pass on their traits, whereas in natural selection, nature or the environment chooses who's going to survive and pass on their traits. Again, it's not like a choice, but it's kind of just something that happens depending on who blends in better or who can get food better or who can withstand the temperatures better and things like that. Okay, choose the best definition of an adaptation. I actually give you the answer in the last video, so if you are confused about this question, I would just go check out yesterday's video. I actually give a lot of the answers to these questions in the last video, so as long as you watch that, you probably did pretty well on this assignment. So here were some questions that kind of stood out to me that you guys brainstormed yesterday. A big one was, does every animal go through natural selection? Like, is this something that happens to all animals in the wild? And I want you to kind of think about that and think about other animals you've either seen in the wild or elsewhere and think, do you think that that animal may have at one point gone through this process of natural selection? Do you think at one point they came from an ancestor, that ancestor maybe moved around, moved to different areas, and then the ones that had adaptations that helped them survived, and the ones that didn't died? So I really want you to think about these questions yourself, because I think we're at the point where we can kind of use what we know to tackle some of these questions. Another really awesome questions are, do humans adapt to their environments like foxes, moths, and mice? It's a really awesome question. Now, what I think about is in the wintertime, if I go outside, or if all humans were to go outside in the wintertime, would this process happen to them? Would humans be able to adapt to their environments? I don't know about you, but I kind of put a jacket on, put a scarf on, some gloves on. So I'm not sure, because humans have so much technology, if we rely on this idea of survival of the fittest, of some humans will survive and some humans will die and pass on those traits and so on. I think that when we have an issue such as vision, we don't adapt to the environment. It's not like all babies, who don't have good vision are out in the wild competing for food, and the ones that don't have good vision won't get as much food, and the ones that do will. We just kind of put on glasses. We also get our food from the grocery store. So we don't really have to compete that much, but I would like you to think about, do humans have to adapt to their environments like foxes and moths and mice? Can mutations be a good thing? And what causes mutations? I want you to think, can mutations be a good thing? In moths, was that dark color mutation a good thing? In humans, is sickle cell ever a good thing? And that goes back to the E level from yesterday. So I do wonder if mutations can be a good thing. Are they bad things? Are they just kind of neutral sometimes, like they happen, but they don't really give an advantage or a disadvantage? So that's a really good thought question. What causes mutations? That's a really awesome question. Mutations actually can happen naturally, just like in the process of creating new organisms. There's a lot of things going on, so it can just happen naturally. But I do also know that like radiation could cause some mutations and things like that. So I think a mix of both. But you could actually look into some of these questions. I am going to give an opportunity to do some Googling in the next couple days. I loved this one. Blending in seems to be a really big deal. What other traits are helpful in survival? I want you guys to think about that. Think about the foxes. What other traits do they have other than their coloring that help them survive? Do animals breed with other animals that help their babies survive better? I love that question. Like, are animals picky about who they mate with? Are they going to pick a mate that's going to help them survive better? Love these questions. So I really want you to think about them rather than me tell you the answers, because honestly, my answers, I'm not Googling them. I'm not doing anything. I'm just thinking about them. So I want you to think about them too. Do animals adapt for reasons other than predators? That's an awesome question. You guys had such good questions. So again, I like have an answer in my head and I almost just started thinking out loud, but I really want to give you an opportunity to think about some of these questions, because I think if you think hard enough, you can figure them out too. So that's what I love about this. This was another question from yesterday. So it says, sickle cell anemia is a hereditary condition that's more common amongst people with sub-Saharan African descent and can cause major medical problems if you carry both alleles for the disease. So we learned about this. If you have sickle cell disease, Super painful. We watched the documentary about Helen trying to get cured. If you have sickle cell trait like Ryan Clark, you could probably be fine your whole entire life, unless you decide to play football in Denver, and you might not have any medical side effects. So scientists actually noticed that there was a correlation between sickle cell trait, people who carry the trait but don't have any kind of medical issues, and malaria, which is a parasitic disease common in sub-Saharan Africa. Malaria is carried from human to human through mosquitoes. It travels in the bloodstream of humans and multiplies, making you sick on round red blood cells. Now, that's the key there. Once malaria has multiplied, symptoms include high fever, chills, sweating, nausea, vomiting, and it can be deadly. So according to our model of natural selection, traits that aren't fit for environment or harmful should probably die out of the population over time, like that light-colored moth in the dark-colored trees. Well, light-colored moths should die out because they don't fit in. It's not good. So why might we continue to see sickle cell in the population? Well, you have to now think about, could sickle cell technically be a good thing when it comes to malaria? So if you didn't get a chance to tackle this question yesterday, I want you to think about it. And think about how sickle cell might actually be a beneficial mutation in some circumstances. With Helen, definitely wasn't beneficial. She had the full-on sickle cell disease, made her really sick, really painful. But I want you to think about this in terms of malaria. Very interesting twist on things. So again, some key ideas that keep coming up are time or multiple generations, variations, the fact that the offspring all look a little bit different from each other, some better than others in the environment, therefore surviving, others not so good and dying, and environmental changes or pressures. So those are some key ideas. So today what we're going to do is put all of that to the test, and you are going to play the game, the survival game of Who Wants to Live a Million Years, and then you're going to complete assignment 14. So in this game, you are choosing organisms, and then they're going to go through various obstacles, there's going to be super cold temperature. Well, I won't spoil it, but you're going to have to survive this game. So your goal is to play until you survive. I had to do it 5 times. It was not super easy. But it was really cool because you can add mutations in. You really have to think about what traits would be helpful in surviving. And then once you play the game and you get to survive, you can fill out this Google form just to tell me how you did. So I hope you have fun playing this game. I hope it kind of ties together all the things that we've been learning about. And once you're done with that, you're done with science for today. So I hope you have an awesome rest of your day. Have a great Wellness Wednesday if I don't talk to you until then. But let me know if you've got any questions. Hopefully things are kind of coming together and you're like, wow, I get how foxes and mice and moths could all be pretty similar. I can see how they change depending on their environment over time, because initially I think a lot of us thought, a fox goes to the Arctic and then just poof, turns white. But now we're realizing it's much more than that. So awesome job so far. Excited to continue to see your ideas, and have a wonderful rest of your day and have a wonderful Wellness Wednesday.